G'day, my name's Graham. I'm old enough to have been studying the planet for many, many years, 60 years. There are many ways to study the planet, but the best way is to study it from the internals. And that way you can get a bit of a grasp of how the whole thing works. And you might then get a grasp of how climates change from within the planet and affected by the sun, and are not changed by human beings affecting the atmosphere. Now, there are a lot of, if you like, misconceptions going out there, and also misinformation when it comes to various aspects in regards to climate change and what's happening within the context of that. And in one part of that is the Antarctica. Now, I watched a report just by chance yesterday on PBS that says the Antarctica is losing this amount of ice. Well, it's bound to, and there's a reason for it. What is happening at the Antarctica? I mean, first of all, the ice on the Antarctica is melting from the bottom, not from the top. It's minus many degrees at the top of the ice. So therefore, to say it's an atmospheric thing that's causing ice on the Antarctic shelf, the continental shelf itself, to be melting, or the water underneath the ice to be melting next to the rock. To say that's a climatic problem, I mean an atmospheric cause of that, is obviously wrong for a start. If you put an ice block on, say, a warm plate in a fridge, it will melt. A freezer will melt from the bottom, not the top. But the thing about it is, it's a geological factor that the more, say, sediments in the sea millions of years ago were settled down, animals, little tiny animals with very little skeletons, all made the sediments in the sea, which make the massive amounts of limestone. Now, it then compressed with a massive amount of forces upon it. Then it becomes things you can carve beautiful statues with. Now, or make buildings out of, because limestone becomes extremely hard. Now, and limestone is also sometimes soft. It hasn't been so compressed, like in, say, the north of England. The limestone is quite soft and easily mined and used for industrial and cement purposes. But the thing is, what they're not saying about the Antarctica gives you an indication how much they're unwilling to say about the true conditions of the planet Earth, because they do not want people to become alerted to the fact that climates change naturally and usually from within the Earth, like I've just said. Now, what's happening in the Antarctica with miles and miles of ice on top of the crust, the plate itself, the continental plate, which makes up the Antarctica itself, the Antarctica continent, which is as large as America and Mexico combined. Where it is on the planet, on the South Pole, it's been drawn in by the gravity. It's been pulled in by the gravity and the air pressure, of course. But everyone thinks things are forced down because of gravity. When you jump up in the air, well, gravity pulls you back down. You don't fall down, you are pulled back down to the ground. Well, the Antarctica is getting pulled into the Earth by the massive ice built up over the millions of years. And that massive ice is pushing the crust, the crust of the Earth itself, which is the Antarctica continent itself, into the Earth, and that's causing a massive amount of heat at that part of the world, in particularly when you take into consideration the important bit about this is that being a magnetic field as well involved in that somehow amplifies the amount of heat that's going to be involved in there, because you've got the Earth is like a dynamo inside, which I'm going to go into the details of that. The Earth is a dynamo inside, and it oscillates as it goes around the sun. It turns around, oscillates at a sort of outer rhythm oscillation, if you like, and that outer rhythm oscillation that change then gradually, because of where the sun and lunar cycles are, eventually causes the poles to flip, which we know is a fact. And that's part of the dynamic cycle of the Earth. The thing about that is that, you see, some people think we're going towards a pole shift, which may not be for thousands or hundreds of years yet, but it's on its way. That's something we're pretty certain about. So, because the pole is already moving, we know in the northern hemisphere, one way or the other, it's accelerating. So therefore, if the pole is a straight line, it's also moving in the south. So that dynamism as well is also affecting the thermal dynamics within the geology of the Earth, between the mantle, that's the hot part, and the crust. So that actually, because the Antarctic's pressure into the crust by many, many meters, 80 meters, each branch of pressure is pressing the crust down. And that's pushing geological pressure, billions of tons, into the geology itself and into the mantle. And that's driven off, that pressure alone is causing a massive amount of heat and gases given off under Antarctica, which must be released somewhere. It's got to be released somewhere. Also, at the same time, when this plate pushes down, because all the tectonic plates are counterleaving arches. That's what they are. If you look at the world as a ball, look at the tectonic plates, they're sort of an arch that's counted upon another arch. Although they have subduction zone where one arch goes underneath the other like that, but nonetheless, it's arches. The world's a series of arches. Simplest way of seeing it. But the arches are moving because of all the various dynamics of the Earth. It's spinning and oscillating and they wobble and stuff like that. The pressures of the Antarctic and continental plates, the masses like the land masses of the Andes and all that all combine to affect the movement of the crust itself. Now, we know that the poles shift, we know we have ice ages, we know that ice age ends, and you've got to say, why do ice ages end? Well, there's many theories about that, but one theory is it's called pressure cooker theory, and that is eventually there's that much ice on certain parts of the world that then causes the world to burst. It seems, if you like, because the pressure's there. And it gets a bit of a wobble up because it's top heavy. And then the pressure bursts and then it suddenly collapses the ice age, if you like, or the ice sheet, if you like. But when it comes to Antarctica, what they're not saying on these reports on the TV and in the media is the massive pressure of the ice itself on top of the crust, the continental shelf itself, is also a pressure, but that pressure is causing the ice to melt. And when it goes out to sea, all the ice is spread over the sea. Well, what happens is that's a sort of a lamination of ice. Millions of each year is a lamination layer of ice. Well, when it gets spread out over the sea far enough, when those ice shelves get spread out over the sea, when the Antarctica, as it gets pushed in as more ice builds up on the top, well, they just snap off from the bottom. The sea lifts up, they're floating. They float on ice, floats on water. They get out far enough, and it's leverage becomes a leverage matter then. The far enough out, the arm of ice is far enough out to sea. In that, then the ocean movement of the ocean contact with the movement of the land mass itself slightly going down. It only doesn't have to go very far. You can actually say it would press down 1 centimetre. And each moves so many tons of ice each year create more and more pressure. So say 1 centimetre down in one spot, and you've got 100 kilometres of ice, well, and that stays level or out at the far end of it, then you're bound to get a crack of several meters because of the angles. It's just a matter of angles and geometry then. What says, well, it's going to crack. You get these really big cracks. So it's called geometry because how far it is out at sea. If it was not very far, the split would be very small, or wouldn't be small at all. But because it's a long way out, then the cracks are large and they break off and float away. And everyone wants to have a big panic about it but now they know that the Antarctica has been building up this massive amount of ice. getting to a stage where it gets so much, it starts putting pressure onto the crust. That then starts these fingers of ice sheets going out to the sea and breaking off. Then more and more, because of the pressure, is giving more heat into the oceans itself around the Antarctic. It's got live volcanoes, remember, and warm areas, and then that is also warming up the rocks underneath the Antarctica. That's going into the Antarctica itself, and that's melting the ice. And when after a while, in who knows, hundreds, thousands of years from now, when it's got to a equilibrium, the Antarctica will start springing back up again, right? And the cycle will all start over again. Because they know that it's gone on, they know that it's been cycles. It's called isostasy. It's something that all these climate scientists and all these climate politicians and all these people don't want to mention isostasy and use static fluctuation, which is isostasy is where the plasticity, if you like, of the Earth's crust means that if you get a pressure one place from a continental shelf pressing down, then it may kind of cause upheavals at another place, because we don't really know what's underneath the crust. We don't know enough about it to ascertain exactly what's under there, how hollow it is, how solid it is, the density of the mantle itself, and how gaseous it is, or whatever it is within the geosphere of the Earth itself. So you can see, and I haven't got a chalk and board to do this, but use your imagination, and you can see the pressure on the Antarctica is causing the heat, because of geological pressure on rocks anyway, causes heat to make, to glaze sandstone. It squeezes sandstone hard, so hard it becomes extremely marble, or whatever it turns into, right? And it also, the rocks become igneous, become very hot and melted because of the amount of pressure. Ones what were on the surface, ones were pressed into, solid rocks, like trees and swampy flora are pressed into coal and shale. So you can see there's a process going on there, and that's because the heat's bonding all these compounds together and these minerals together, and the heat is pressing on the ice, melting the water, but also the heat coming up from the rocks is also melting the water. The water then causing the glaciers to slide out. And they say, oh, it's to do with atmospheric warming. Well, not really, because if you consider the actual facts and take them into consideration with the past records of the Earth itself, instead of going on about a few records the last 10 years or so, then you can see for yourself that the dynamics within the Earth itself, given the solar, the lunar and solar cycles, it makes also a difference how that plays on the crust. So it's all quite complex. But it's not that complex if you can draw it with a chalkboard. You can draw this up. It then becomes easier to explain, and I haven't got that sort of equipment. But that's something maybe I'll try to arrange. But it's something that I do not believe anyone who's pushing an agenda about this human climate change, because it's not an even political system anyway. It's the Chinese are allowed to pollute and carry on pushing much more CO2 into the air, and no one says anything about it. But in America and Australia and that, we're supposed to cut out all the CO2. The politics is raving on about how it must cut out all our CO2, while China's going ahead building more and more coal-fired power stations. So you can see that there's something wrong there, not just in the science. If the science was consistent with these political beliefs, then they would have China right now. They'd be saying, you must stop your CO2 production right now, and India, because they're going to be the greatest causes of this devastating climate change if the anthropogenic theory is correct. The fact that China is allowed to continue and India is allowed to continue means they don't actually believe it's correct at all. In fact, because it's not correct. I mean, it's not correct. You can go on for days about this and prove that it's not correct. Humans make 5% at the most of all CO2. Australia makes 0.002% or something like that of the whole of the thing, and it's insignificant. Yet it's all panicking about it. And it's panicking because the people in top, they don't understand it. Politicians don't understand it. They prove it every time they speak. And the scientists, many people call them climate scientists, don't understand it either, because you need to talk to geologists. They're the real people who understand this. Or someone like myself who just around about study how humans have evolved through many, many different climate changes, which is my own particular interest. But then it covers all these different fields. And anyone can learn these things. Do not never ever let anyone tell you can't learn any part of it, because most of it needs no maths or no physics. It's just most of it's common sense. If you've done mechanics of the car, or you can build something and you can make something, generally you can then understand pressures and be able to understand things like that, and the physics and the physical dynamics. It's not very complicated at all. Pressure on something puts heat underneath it, causes ice to melt, causes magma to interact with the Earth's crust. That causes heat to come up through the Earth, warm the soils up or the rocks up a little bit, just enough, and plus the pressures and the water is melting, and that's what's causing the ice to be melting in the Antarctic. It is not caused by atmospheric temperature rises. That makes no sense, given 6 months of the year it's dark and well below freezing.